A pen is placed in front of and to the right of a plane mirror as shown. Where is the image of the pen? So this is the pen and this is the mirror. And they're asking, where is the image? Is it at A, B, C, or D? So how would we locate that image? Rules we learned were to create, the distances first. The object distance for a mirror should be equal to the image distance. Remember that? Recall that? Then what we did was we drew a line from the image to the observer's eye. So this basically answers this question that my image is at point C. Since C fits these this light ray here and this distance term here. But am I being clear? Am I understood?
Yes.
Then 19. It says 3 students stand 2 meters apart in front of a plane mirror which is 3 meters long. Student Y is standing opposite the midpoint of the mirror. So that is 1.5, okay, here. How many students can see the images of the other two? So is it no students that can see the image? Is it one student that can see the image? Is it 2 students or is it 3 students? So again, how would I work that? Let's consider this student X as an observer. That means the image of student Y would be here. And from this point here, a line or a straight ray to be drawn from this point to the observer's eye. So if it goes straight to student X, since I'm unable to, draw a line straight here. So if it goes straight, it would be visible to student X. Then if we work out student Z, it says this would be the position of the image of a student Z first, then from this point to student X. That would be obviously a straight line drawn easily. So X can see Y and Z. Am I right? Hello? Am I right? Am I understood?
Yes.
And if we replicate the same case to student Z, since all the distances and positions are identical, student Z, I guess, would be able exactly to see student X and Y by the same proposition. Am I right? So this creates that 2 students are able to see the image of the other 2 students. So if we talk about student Y in the other case, how would we identify that? So let's see. If student Y is here, so image of student X would be here and student Z would be here. So then we have to draw a straight line here and here. That enables what? That enables that the student Y would be able to see the images of both of the students. That means all 3 students are able to see the image of the remaining 2 students. Am I right? Am I clear? Am I understood?
Yes.
Okay, next question says this figure shows an air bubble. Okay, this is an air bubble, this is water. The ray of light are incident on the air bubble. So these 3 rays are incident upon this air bubble. The angle of incidence of ray 1 on the air bubble is greater than the critical angle. So this is here, whatever the angle of incidence, it would be somewhat like this. If we draw a normal on the surface of the air bubble, so this is this angle of incidence is more than the critical angle. So if we recall the condition, what happens if the angle of incidence is more than the critical angle? And the second condition was from a more optically dense medium to a less optically dense medium. So light would be totally internally reflected back. So angle ray 1 should be diverted somewhere here such that angle of incidence is equals to angle of reflection. Then it says the angle of incidence of ray 2 on the air bubble is less than the critical angle. So if we talk about the angle of incidence of ray 2 on the air bubble, so is less than the critical angle. So how would I proceed here? Any ideas? So if it says it is less than the critical angle, then if I draw a normal here, so this would be angle of incidence. And then if we talk about if it is less than the critical angle, that means it would be a perfect case for refraction. So that means it would be reflected here. Am I right? Because this is a more optically dense medium, this is a less optically dense medium. So angle of incidence would be smaller as compared to angle of reflection here. So it would be somewhere here. Then it says ray 3 is perpendicular to the surface of the bubble. If we talk about a perpendicular ray being striking any surface here, so it remains undeviated. It passes straight through it. So this is what I tried. I never read the question, but I knew that they're going to ask us up. The angle of incidence of ray 2 on the air bubble is 27 degrees. Okay. So ray 2 is 27 degrees. The angle of refracted ray of incidence is 37 degrees. Okay. On figure 4.1, at the point where ray 1 meets the air bubble, mark the normal to the surface. I already did that. The angle of incidence, I still already did that. Complete figure 4.1 to show all three rays continue after they meet after this bubble. So this has already been done. Define what is meant by refractive index of water. So how would you answer this? Refractive index of water. So I can answer it as ratio of speed of light in air, that is air bubble here, to the speed of light in water would be the refractive index of water. Then it says calculate the refractive index. So how can I calculate the refractive index? I can use the formula N equal sine angle I over sine angle R. So where it was already mentioned here, angle of incidence 27 and angle of refraction is 37. But I would take this as angle of incidence and this as angle of refraction because a smaller angle is always angle of refraction. So I would write according to this formula sine 37 over sine 27. So it comes out to be 1.32. And refractive index has no unit because it is a ratio between two similar quantities. Okay. Then if we move on to the last part of this worksheet, it says on figure 4.1 shows a ray of light incident on a mirror at X. The incident ray makes an angle of 50 degrees with the surface of the mirror. Complete the figure 4.1 to the normal to show the normal and the reflected ray at X. So I can draw normal here and I can mark this as 40 degrees and the reflected ray would be again marked at 40 degrees. Then it says state the values of this is already done. Angle of incidence 40 degrees, angle of reflection 40 degrees. Describe with the help of a ray diagram how would you find the position of the image produced by the plane mirror. So this is what we already discussed in the class. That if you recall, you can start up with a plane mirror here. You can write some letter here. Let's say F here. So it would be created somewhat like this. Then let's put an observer here. So first point here goes to this point here. Then let's say it goes to this point here. And from these 2 points, you create light phase exactly towards I. This creates the angle of, refraction. Reflection. So first ray striking here is incident 1. Second ray striking here is incident 2. So this creates incidence, reflection, incidence, reflection. So you can write this all. Am I being understood, Peter?
Yes.
Any questions so far up till here?
सर इससे पहले वाला जो पेज था उसके जो डायग्राम है वो आप वापस लगा सकते हैं स्क्रीन पर.
I'm sorry, I won't be able to do that since that was an annotation. Here, 4.1.
Yes.
But the class was recorded, so I'll share the recording so that you can see that. What the
Okay,
student.
Jazakallah. Yes, Jazakallah.
Okay. Take care. We can keep things up till here. Till then, Allah Hafiz.